Okay, can you people hear me? Hello, Shomita, Sokrit, can you people hear me?
Yes, sir.
Yes,
Anandit, Devang, are you people able to hear me?
Yes, sir.
Yes, good evening, Sarthak, can you hear me?
yes, sir. Good evening, sir.
Sarthak, after 2, 3 years, you're joining the class. What happened? It's
Sir,
been ages.
last Tuesday,
Last you
in the
joined my class during Stone Age, and now you're joining the class. What happened? So long?
the exams were going on.
For so long?
Sir, like 2 weeks I didn't join.
2 weeks you didn't join. That counts to 4 classes. How will you cover?
I will see the videos, sir. I started seeing the videos. I will complete it. Right.
Okay. So cover your backlogs. You know that there
Yes,
are too many. Okay. Don't stay behind. Okay. Our next test will be okay.
yes, sir.
PNC binomial test will be taken very soon. Okay. Okay. So let us start. I had given some homework questions. Okay. Can you people see my screen?
Yes, sir.
Okay. Okay. So last day we were doing PNC. I had given some homework questions. I'm going to write down the answers. You people match. Okay. First one, 10 students in a batch. Okay. Let me see. Hmm. Over here, the answer is given as 10C2 into 2 factorial. Okay, everyone pay attention. 10C2 into 2 factorial multiplied by 10C8 into 8 factorial. Anyone having any doubt? Tell me. If there's anyone having any doubt in question number 1, let me know. Okay, next. Question number 2, part A. N minus 2C1. Okay. Sathuk, did you attempt all these questions?
No,
Part
sir.
B. Part B will
But
be
I started
NC3.
from the first video. I will.
Okay. As soon as you go through them, okay, also solve these questions as well. Is it clear?
Yes, sir.
Part C will be N minus 2C3. Anyone having any doubt? Tell me.
So can you solve question number 2?
Question number 2. There are n intermediate stations in a railway line from one terminus to another. In how many ways can a train stop at 3 of these intermediate stations? All of 3 stations are consecutive. If all 3 stations are consecutive, then it is very easy, right? All 3 stations are consecutive.
So first of
This
all, when you were saying about n intermediate station, that means between the first and the last terminus there are n stations, or in total there are n stations.
total there are n intermediate stations.
Ach.
Okay.
I thought
So
it to be n plus 2 number of stations.
no. And intermediate stations. So it can happen that the train is stopping at A1, A2, A3, right? Dot up to AN minus 2, AN minus 1 and AN. You can understand? So what is the number of ways? Number of ways will be equal to n minus 2 C1. Is it clear? Tell me, Socrates.
Yes, sir.
Part B, should I start? Tell me. At least 2 of the stations are consecutive. At least 2 of the stations are consecutive means total minus no 2 stations are consecutive. Right? Tell me.
Yes, sir. So
Total minus.
subtraction. Hmm.
Exactly. So I'll do part C first, then I'll do part B. Okay. In how many ways can you select 3 stations such that no 2 stations are consecutive? In how many ways? So first of all, what you do is you remove all those 3 stations, right? How many stations are remaining? Number of stations remaining after removing. I'll use gap method. After removing, tell me.
-3.
n
n
minus
minus
3.
3. So n minus 2 gaps are found. So n minus 2 C3.
Correct, correct. The rest you can understand, right? Should I complete or it's
Understood,
fine?
sir. Understood. Understood. Understood.
Number of gaps is equal to n minus 2. Very easy. Next. So part B, part C is done. Coming back to part question number 3. In how many ways a triangle can be constructed by joining vertices of a quindecagon? If none of the sides of a triangle, do you remember? Again, gap method for circles. So I think the answer over here you pick 25. If there's anyone having
Sir,
any
I
doubt,
gave you the same answer. You said it was wrong.
I told you wrong. Wait a minute. Let me check. Okay. You gave me same answer. You check what you wrote.
Sir, I wrote 11C, 1 as 10. That's why I got 276. It should have been 11.
See,
So,
see.
but,
That's why. Okay.
sorry, sir. Understood.
Okay. Okay. For part one, there is no restriction. 9 factorial. It's very easy. This one was very easy. 9 factorial. Okay. 5 factorial into 5 factorial. Okay. 4 factorial into 5 factorial. Okay. And the last one is not more than 4 movement. So 9 factorial minus 5 factorial into 5 factorial. Anyone having any doubt? You can ask me now. Tell me.
No, sir.
Okay. Tell me, Shomita, you have any doubt? Shomita, Devank, Radhe, Sarthak,
No, sir.
you people have any doubt? Tell me. Okay. Wait. Okay. Next. Next. This one would be 810. Then 808. Okay. Then number of odd devices 135. Then 675. Then 720. Then it is 600. Anyone having any doubt? You can ask me.
Can
Tell
we
me.
solve this? Like how to solve this kind of question?
These kind of questions. So do you remember I had taught before also in class 9, 10 how to find out the number of devices? Do you remember? We have to factorize it. You have to find out the total number of selections,
Okay. Oh, okay. Like that.
right? If n equal to p1 to the power alpha 1 into p2 to the power alpha 2 into pk to the power alpha k, do you remember?
Yes, sir,
Then
now I
number of
remember.
devices. So should I solve it or you will go through the videos first?
Yeah,
Tell me.
I'll go through the video.
Okay. Go through them. If you couldn't understand, let me know. Okay.
Okay, sir.
Next one, find the number of permutations of 6 digits. Over here, wait, I'm telling you what is the answer given. Over here,
So
the
please
answer is
explain
given
this question.
62. Over here, the answer is given 62. Yes, Pakrit, you are saying something.
Sir, can you please solve this question?
Okay. So it is saying that we need to find out the number of permutations of 6 digits from the set 1, 2, 3, 4, 5, 6, where each digit is used exactly once. So that the chosen permutation changes from increasing to decreasing or decreasing to increasing at most once. Means maximum it should change only once. Right? It can change 0 times or it can change only once. Understood? So I'll form cases. You'll understand. Okay, I'll start with increasing. Okay, let us start. This is number 6. So case 1, it can happen that the digits are in this form: up, 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 and then 6. In how many ways? I mean, you can get a number like this. Tell me. in increasing order? Tell me, Socrates. How many ways? How many
Sir, can you
numbers are
repeat
like
the
this?
question once more?
How many numbers are like this? Okay, you are increasing, kept on increasing. Okay, in the ascending order, if you
So
arrange
one
them,
only, if
only
we are
one,
using each digit once.
only one. Case two. It can happen that you are going up, 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 then six, then down. Right? In how many ways it can be done? Then
Telling
5C1 ways.
5C1, yes.
Case three. Up, 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 then six, then down. Then again it will be down only.
5C2.
5C2. Then 5C3. Then 5C4. Then 5C5. Right. That is only one case.
So 2 to the power 6 minus 2, I think the final answer will be.
Yes. So down. Others have understood. Tell me. Six. Then down. Then down. Then down. Okay. Dot 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 dot. Up to one. Only one case. 5C5. Tell me. Shomita, Devang, Anandit, Raktim. Are people getting?
Yes, sir.
Sarthak, are you getting this one?
Yes, sir.
So how do you get
Yes,
a
sir.
5C21?
This one. Because we need to select two of the numbers. Like already four numbers are. I have already substituted four numbers. How many numbers are
Yes, sir.
left?
So, 2.
Two. We need to put two numbers.
Okay,
Right.
out of 50.
And
Okay.
it can be anything.
Hmm.
Right. Tell me. It can be
Yes,
anything.
sir. Doing. Yes.
Okay. Out of the remaining five. Because six you have already substituted. So
Yes.
5C2. Okay. Similarly, now we are moving on to case number 7. In case number 7, down. Now you start with down. Down, 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 down. Sorry. This one, then down. One, then up, not down. One, then up. Right. This case is also possible because it is written. It can be either increasing or decreasing order. Okay. So once I've done it in increasing order, now let us do it in decreasing order. Okay. So how many cases? 5C1 again 5C2, again 5C3, again 5C4. So the total will be equal to 5C1 plus, sorry, 1 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 1 plus 5 plus 10 plus 10 plus 5. This will give us our answer. Okay, that gives us 62.
Yes, sir.
Okay, is it clear, everyone? Okay. Moving on to the other problem. This one, number 7. Number 7, the answer over here is given as okay. Number 7, 186. Anyone having any doubt? Tell me.
Sir, I have doubt in seven.
In 7. Okay, let
Yes.
us discuss. So, what are the things given to us? Okay, first of all, let us write down all the things that are given to us. Okay, let n be the number of ordered pairs of non-empty sets A and B that have the following properties: A union B is equal to 1, 2, 3, 4, 5, 6, 7, 8, and A intersection B is equal to 5. That means both are separate sets, mutually exclusive events. Right, tell me.
Yes.
Both are mutually exclusive events. Now, it is written that the number of elements of A is not an element of A, and number of elements of B is not an element of B. Okay, so I write it down. Number 1. what are the things we are given over here? Number of elements in A plus number of elements in B is equal to
10.
10. This is one thing given. Next, if n of A equal to 2, means number of elements in A is equal to 2, then number of elements in B is equal to how much? 8. This implies we can say that 2 belongs to B and 8 belongs to A. Right? These are the things we can conclude. Next, I have a question to everyone. Can n of A be equal to 5? Tell me. Can n of A be equal to 5? Yes or no?
No, sir, NA can't be 5.
Na can't be 5. What about others? Tell me. Shomita, Devang,
So
Raktim,
it can't be
Anandit.
5.
It can't be
It
5.
can't.
So Devang, tell me why it can't be 5. What is the reason behind it? There should be some reason, right?
Sir, because if we consider NA to be, I have done it like this. I have taken the number of variables of in A to be K and NA to be in B to be M, right? So K plus M should be equal to 10.
Okay.
And according to the question, K should be greater than or equal to 1 and M should also be greater than or equal to 1.
Okay. So 5 is greater than or equal to 1, isn't it? Why it
Yes.
can't be 5? What is the
And I got a
reason?
relation that and I got a relation that K should not be equal to 10 minus K. And so K should not be equal to 5. That means NA should not be equal to 5.
What? What have you done? How did you get this equation? K equal to 10 minus K. How did you get this equation? This I cannot understand. K, you must have got K plus M is equal to 10. Then how did you get K equal to 10 minus K? This I
Actually, sir,
cannot.
it did a relation that K is not equal to M and M is equal to 10 minus K. So K should not be equal to 10 minus K.
But in the beginning only you assume that K is not equal to M.
Yes.
Why can't
And
they be equal?
now if K is not equal to M and M is equal to 10 minus K, then K is not equal to 10 minus K. I did it like that.
Yes, I understood. I completely understood your solution. My question is, why can't K be equal to M? What is the reason? There should be some reason, right? Why K is not equal to M? You started with K is not equal to M, but why? K can be equal to M, isn't it? Yes or no?
Yes, sir.
But just now you said that K cannot be equal. I mean, if K equal to M, then K is equal to 5 in this case. Right. Your answer and logic does not match. Anyways. Next, anyone else? Yes, Socrates, tell me.
So can
Sir, like if NA is 5, now what is given? That number of elements of is not an element of A. And we know that A and B are exhaustive and disjoint sets. Now, if
Hmm.
NA is 5, that means A will not, A can have all other elements other than 5. Acha.
Okay,
Now, if NA is 5, that means NB is 5. So neither A
correct.
nor B will have 5 as the element. This is not possible at
Exactly.
all.
Exactly. If NA equal to 5, pay attention, Devang. If NA equal to 5, this implies NB will also be equal to 5. Are you getting? This implies that 5 does not belongs to any of them, which is a contradiction. Are you getting? So
Yes,
it is
sir.
a contradiction. Okay, right. Shomita, Anandit, Sarthak, are you getting? Tell me.
Yes, sir.
Yes, sir.
Okay. Next. So let us move on. What are the things possible? 1, 2, 3, 4. All these numbers are possible. Okay. So if NA equal to 1, number of elements in A equal to 1, number of elements in B is equal to 9, we have to start making groups. Okay. We have to start making groups. Means in how many ways Na can be equal to 1 and Nb equal to 9?
So there is just
If
one way.
yes, if Na equal to 1, that means 1 does not belongs to A. Right, tell me. 1 does not belongs to A, 1 should belong to B, and 9 should belong to A. Right. So we need to make a group of the remaining numbers. 1 and 9 is done. 1 is belonging to B and 9 is belonging to A. 1 and 9 is done. So we need to make group of 8 and 0. Are you getting? Tell me. Raktim?
Sir, why group of, can I ask something? Why group of 8 and 0? I mean, whenever you are selecting that NA is 1, NB is 9, the sets are already decided.
Yes, it is decided. That's what I said. That
Yes, sir.
9 belongs to A and 1 belongs to B. Right? Tell me, Socrates.
Yes, so then the number of
So
ordered pairs will be 9 into 1 only.
wait. What I'm saying is 9 belongs to A and 1 belongs to B. Okay, how many more elements are left? Tell me.
8 more elements are left.
8 more elements are left. Out of 8 more elements, how many elements should go to A and how many elements should go to B?
Sir, 8
0
to
elements to A and 8 to B.
Yes. So are you getting why I'm making a group of 8 and 0?
But sir, like my question is that is anyway decided, right? Like,
It is
why do I need to further make groups of it?
groups of.
Achha, you are distributing. Achha, understood. Okay.
Just even if I don't do it, I just write 8C0. That also is correct. Okay. But why
Hmm.
I'm doing it like this? It is required for other cases. Okay. So that you people understand other cases. Understood?
Yes, sir. Yes, sir.
Okay. Tell me, Raktim, are you getting? If n of A equal to 2, that means n of B equal to 8. So over here we need to make group of over here we need to make group of how much? Tell me. 1 and
7.
7. That can be done in 8C1 ways. Right. Next. If n of A equal to 3,
7 7.
why 7C1? Total number is 1 plus 7, 8. Na?
Oh, yes.
N of B equal to 7. In this case, we need to make group of 2 and 6.
2
So
and 6.
8C2. Okay, then I'm writing it down separately. Okay, 8C2, 8C3, 8C4 is not possible. 8C5, right? 8C4 is not possible. You can understand. 8C6, 8C7, 8C8. Done. So number of ways will be equal to. Tell me, Raktim, is it clear?
Yes, sir. Now it is clear.
Okay, it's proper mains level question. This kind of questions you can expect in mains. Plus 8C2 plus dot plus 8C8 except 8C, 8C3, 8C5 plus dot. Okay, so we can write it as 8C0 plus 8C1 plus 8C2 plus 8C3 plus 8C4. I'm adding 8C4 and subtracting 8C4, okay? Plus up to 8C8 minus 8C4. So from here to here, it is 2 to the power. What is the sum of all the binomial coefficients? 8 minus 8C4. This will give us 256 minus 8C4. So 8 into 7 into 6 into 5 divided by 24. Okay, 24 times 6 times 4, 4 2.
70, I think it would be.
So this will give us 256 minus 70. That counts to 186. I hope it is clear to everyone. Next. Next one is find the sum of all 4-digit numbers that can be formed using the digits 3, 2, 3, 4. Over here, the answer is given as 30. No. 3,996. Anyone having any doubt, you can ask me now. Tell me. Anandit, Raktim, Devang, Shamita, Sokrit, Sarthak. Do people have any doubt in this
No,
one?
sir.
No, sir.
Next one is 5, 6, and 2 zeros. Okay. Next, number 10. Find the number of permutations of the digits 1, 2, 3, 4, and 5 taken all at a time so that the sum of the digits of the first two places is smaller than the sum of the digits. So over here, the answer is 48. Anyone having any doubt, you can ask me. Number 11, 36. Number 12, 536.
So can I solve number 12? I mean, what to do with 4x4? Can we treat it as separate variable? Let's say y1 or something.
No, with 4x4, you can understand that the last term can only take multiples of 4, right? So what you do is you can take cases simply. This is number 12. Okay, so Socrates, what you do is if x4 is equal to 0, what is the equation? X1 plus x2 plus x3 is equal to 20.
Sir,
What do
but
we
it is
need?
given non-negative integral solutions, right? So,
So non-negative
sir, zero, you're
integral.
not count, not, okay. Okay.
0 is a
So we'll
non-negative
make cases
integral.
now, right? When
Yes,
x4 will be taking values in multiples of 4. I mean, the whole
exactly.
quantity. Okay.
Exactly. X4 is equal to 0.
Will the answer be
Okay.
500 something? 536?
Yes, answer is coming as 536. Should I solve or it's done? You can solve it.
I can solve it, sir.
Okay, 536. Number 13, the answer is 136. 17C2. See, it came in JEE Mains 2024. 14 also came in Mains. The answer is 234. Anyone having any doubt, you can ask me now. Tell me. Shamita, you have any doubt? Tell me.
No, sir.
Shamita,
So
Socrates.
14 can you solve once? I mean,
Yes.
total number of numbers will be 12, right? 12 such numbers.
Yes, we need to find out the sum of all distinct numbers that can be formed with the digits 1, 2, 2, and 3. Okay, so let us start. 1, 2, 2, and 3. So it's a 4-digit numbers. What is the number of numbers?
Distinct numbers are talking about, so it should be 4 factorial by 2 factorial.
Yes. Number of numbers will be equal to 4 factorial by that gives us 12. Remember. Okay. So we need to find out 4-digit numbers. 4-digit distinct numbers. Okay. So we need to find out 4-digit distinct numbers. Okay. Think about the units sheet. Okay. 3 will be in the units place. How many times?
Once.
Only once. What? Once?
So, I mean, no, once means in one set total. So,
12 divided by 4.
4, 3
3.
times. 3 will be there 3 times.
3 will be there 3
Hmm.
times. Okay. 2 will be there 6 times.
But will we
And
count it that way? I mean,
yes. Why not? Okay.
but they won't some numbers be then repeated then?
Why will it be repeated?
If you are taking 2 6 times, 1 2 is there at the unit digit. Another,
Think about the symmetry. There are 12 numbers. 3 cannot be more than, like, I'm telling you will understand it now. Okay, thinking about the first 3 digits only. Acha, wait. Let us think about the first 3 digits only. Okay. And then we'll think about the unit seed, what to place. So if the unit seed is 1, okay, let's see how many numbers are there. Only three numbers, right? If the unit seat is 3, how many numbers are there? Tell me.
Three numbers only.
Only three numbers, right? If the unit seat is 1, number of numbers is 3. If the unit seat is 3, number of numbers is equal to 3 only. So the remaining there are how many cases? Tell me. 6 cases? Yes or
That's
no?
right.
What substitute? Tell me in the
Two,
units place.
two,
2
two.
only. There's no other choice only. Do you have any choice? No. Okay. So 2 will come 6 times. Okay. So I'm calculating for the unit seat. Okay. For the unit, for each and every digit, it will be the same calculation, right? So it will be 12 into 1 plus wait, not 12. Wait. It will be 3 times 1 plus 6 times 2 plus 3 times 3, right? Multiplied by. This is for the unit seat, then tens digit, then hundreds digit, then thousands digit. Okay, I think this should give us our answer. Okay, 3 plus 12, 15, 15 plus 9, 24. 24 into 1, 1, 1, 1. Okay, 1, 2, 3, 4 ones. Okay, so what is it coming as? What do you think, everyone? Am I getting my answer? Tell me. Am I getting 2 666 4? Tell me.
Yes, sir.
Okay. So Socrates, is it clear?
Yes, sir. Yeah.
Okay. So I think we can continue, everyone. Okay, Raktim, Anandit, Sarthak, Devang, you people have
Yes,
any
sir.
doubt? Shomita,
Okay.
you have any doubt?
No, sir.
No? Okay, so I think only one last topic is left. Last day we have done maximizing NCR, grid problem also we have done. 9C4 into 6. Okay, last problem, everyone. Last topic. This topic is really very important, everyone. A lot of questions have come in the past. And if questions come from this topic, if you know the concept, then only you will be able to solve it. Otherwise, it is very difficult to solve. Okay, derangement. Okay, derangement. So what is derangement, everyone? I'll give you a definition. Okay, number of ways to put n letters in n envelopes such that none of them goes to the designated envelope, to the designated envelope. Okay, is derangement of n things, is derangement of n things denoted by dn. Okay, so what is dn? Dn is equal to n factorial. Okay, I'll write down the formula. N factorial multiplied by 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. Remember the pattern, dot, 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 minus 1 whole to the power n upon n factorial. So tell me, everyone, I'll show you the proof. Okay, there are two methods of proving this one. Which one should I show? Tell me. One is with recurrence relation. Other one is with pi, principle of inclusion exclusion. Tell me, which one would you understand more? Or both? Tell me. Which proof you want? Recurrence or pi or both? Tell me. Hello. What happened? Acha, I'll show you both. Pay attention. Method 1. So there are n letters. L1, L2, dot, up to Ln. Total n letters are there, and in total n envelopes are there. Okay. So you people tell me, this L1 has how many choices for dearrangement? Not arrangement, dearrangement.
N minus 1.
L1 has how many? N minus 1
N minus
choices. Here, L1 has n-1 choices. Okay, everyone? L1 has n-1 choices. Okay. Now, among these n-1 choices, I'll take one case. Okay. I'll take one of the case. So if L1 goes to E2, if L1 goes to E2, okay, L1 can go to E3, E4, anything. Okay. But I'll take one of the case. Later on, I'll multiply by the n-1. If L1 goes to E2, okay, we proceed with L2. Okay. And if L1 goes to E3, we proceed with E3. Okay. So if L1 goes to E3, we proceed with E3. Okay. We'll look at E3 now. Sorry, L3. Okay. So everyone, if L1 goes to E2, if L1 goes to E2, okay, and then L2 has two choices.
N minus
Okay.
1.
How what?
L2 will have N minus 1 choices.
L2 will have n-1 choices. Definitely it has n-1 choices. L2 can either go to E1 or it can go to any of the E3 to En. Right, tell me everyone.
Yes, sir.
Yes, sir.
If L2 goes to E1, okay, I mean L2 has n minus in total n-1 choices. Okay. So everyone, if L1, okay, now try to understand everyone. Now think like this, okay, that L2's designation has changed. Okay, it has changed to E1. Okay, because now if L2 goes to E1, how many letters we need to dearrange? Tell me everyone. If L2
N
goes to
minus 2.
E1,
N
n
minus
minus
2.
2. Right. Okay. So again, we'll come back to the same process which we have started with L1. Okay. Same process we need to repeat with L3 now. Okay. So let us come back. So if L1 goes to E2, okay. If L1 goes to E2 and L2 goes to E1, okay. Then we need to dearrange how many letters? We need to dearrange how many letters? n-2 letters, right everyone? Tell me.
Yes, sir.
We need to dearrange n-2 letters. Tell me, Shomita, are you able to understand this part?
Yes, sir.
Okay. Devang, Anandit, Raktim, are you people able to understand?
Yes, sir.
Yes, sir.
Okay. And what will happen if L2 doesn't goes to E1? Means L2 is also not going to E1. L2 cannot go to E1. So how many letters we need to arrange now? Number of letters to dearrange will be equal to n-1. Tell me. That means we need to dearrange L2 also. L2's designation has changed. Okay. Now we need to dearrange L2 also. Are you getting? Tell me everyone. Okay. So either of these two cases will happen. Right. So can I say dn will be equal to either you have to dearrange n-2 letters or you have to dearrange n minus 1 letters. And like this, there will be how many cases? Like this, there will be how many cases? N minus 1 cases. Tell me, is it clear to everyone? This is the recurrence relation for dearrangement. Anyone having any doubt? You can ask me now. Tell me. Raktim, Sokrit, you people have any doubt? Tell me.
No, sir.
Devang, Anandit, Sarthok, Shwamita, you people have
No,
any
sir.
doubt? Tell me.
No,
Okay.
sir.
This is a recurrence relation for DN. Okay, it's quite important for Olympiads. Okay, if you wish to give any Olympiad or ISI CMI exams, okay, then this kind of things are helpful. Then DN minus n into DN minus 1 will be equal to DN minus 2. Sorry, n minus 1 into DN minus 2 minus DN minus 1. Okay, now look at this relation, everyone. Okay, after opening the bracket, look at this relation. You'll find a symmetry between both the sides. Okay, let us say instead of n over here, look at the left hand side, don't look at the right hand side. Okay, on the left hand side, if we replace n by n minus 1, what will you get? You'll get dn minus 1 minus n minus 1 into dn minus 2. Right, tell me everyone. If you replace n by n minus 1, you will get dn minus 1 is minus n minus 1 into dn minus 2. Yes or no?
Yes, sir.
Okay. Is it similar to the right hand side? See, right hand side and left hand side. Now the new equation and this equation, they are negatives of each other. Yes or no? Are you people able to see? They both are negatives of each
Yes,
other.
sir.
Okay. So what I'm going to do is I'm going to take another sequence. Let Tn be equal to dn minus n into dn minus 1. Okay. So what am I getting? We'll get Tn is equal to minus of Tn minus 1. Tell me, is it clear to everyone? If you didn't understand, you can ask me now. The right hand side is tell me, Raktim, Devang, Anandit, Sokrit, are people getting?
Yes,
Yes,
sir.
sir.
Okay, okay. After coming up to this conclusion, okay, let us find out some values. Okay, let us find out D1, D2. Okay, I mean D1, though it's not possible only. D2, let us find out D2. Can you people understand the number of ways to dearrange two letters? Okay, let us call this equation 2. Let us call this equation 1. The number of ways to dearrange two letters. In how many ways can you dearrange two letters? L1 has to go to E2. There's no other choice. L2 has to go to E1. There's no other choice. So the number of ways to dearrange two letters will be equal to 1. Next, let us talk about D3. Okay, now there are how many letters? There are 3 letters. Okay, now there are 3 letters. Okay, let us calculate D3. So over here, one of the possibility is that L1 can go to E2, L1 can go to E3 as well. Okay, L1 can go to E2 and L1 can go to E3 as well. Okay, so if L1 goes to E2, where should L2 go? E1 or E3? Tell me. If L1 goes to E2,
E3.
L2 should go to E3. L2 cannot go to E1 because if L2 goes to E1, then L3 has to go through E3, which violates the definition of derangement. L3 has to go to E1. This is one of the possibility. Are you people able to understand? Tell me. Next, another case. Another case can be L1 goes to E3. Where will L2 go? Tell me. Where will L2 go? L2 has only one choice. Tell me which one? E1? Tell me, are you getting everyone? Sokrit, Shomita, Raktim, Anandit, Devank, are you people getting? Tell me. And L3 has to go to E2.
Yes, sir.
Okay. So what is the number of cases? D3 will be equal to 2. Okay. So what have I got? I have got Tn is equal to minus of Tn minus 1. So over here, let us find out what is T3. T3 is equal to D3 minus 3D2, which will be equal to 2 minus 3, that is minus 1. Okay, T4 is equal to minus T3, which is equal to 1. T5 is equal to minus 1. T6 is equal to 1. So can I say that T is equal to minus 1 whole to the power n? Tell me everyone. Can I say that Tn is equal to minus 1 whole to the power n? Okay, next. So what am I getting? What is Tn? Tn is equal to Dn minus n into Dn minus 1, which is equal to minus 1 whole to the power n. Okay. Now I'm going to divide by n factorial to make it telescopic. This implies Dn by n factorial minus Dn minus 1 by n minus 1 whole factorial is equal to minus 1 whole to the power n upon n factorial. So see, it becomes telescopic. This is Fn minus Fn minus 1. Are you people able to understand? Tell me. Raktim, Anandit, Devank, Shomita, are you getting?
Yes,
Yes,
sir.
sir.
Okay, Sokrit, are you getting?
Yes, sir.
Sarthak, is it clear?
Yes, sir.
Okay, now I start substituting the values of n. Okay, we can start by n equal to 3. For n equal to 3, what are we getting? We'll get d3 by 3 factorial minus d2 by 2 factorial is equal to minus 1 by 3 factorial. Okay. Next, for n equal to 4, we are getting d4 by 4 factorial minus d3 by 3 factorial is equal to minus 1 by 4 factorial. Okay, for n equal to 5, d5 by 5 factorial minus d4 by 4 factorial is equal to minus 1 by 5 factorial. Okay, dot 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 for n equal to n, dn by n factorial minus dn minus 1 by n minus 1 whole factorial. This will be equal to minus 1 whole to the power n upon n factorial. So when you add, you see all the middle terms gets cancelled. Okay. Finally, you are going to get dn by n factorial minus d2 by 2 factorial is equal to minus 1 by 3 factorial plus 1 by 4 factorial. Okay, dot 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 minus 1 whole to the power n upon n factorial. Okay, d2 is 1. So taking it to the right hand side, we are going to get dn by n factorial is equal to 1 by 2 factorial. Are you people able to see that we are getting the proof? Tell me.
Yes, sir.
Minus 1 whole to the power n upon n factorial. Okay. So see, it starts with 2. Okay, you can just add and subtract 1 by 1 factorial and 1 by 0 factorial. So dn will be equal to n factorial into 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial dot minus 1 whole to the power n upon n factorial. Tell me, is it clear to everyone? Anyone having any doubt, you can ask me now. Tell me. Sokrit, Devank, Raktim, Anandit, anyone having any doubt? Shomita, is it clear?
Yes, sir.
Okay. Acha, method 2. Principle of inclusion exclusion. Okay. So let us take an event A1 such that L1 goes to E1. Okay. Let us take another event when A2 goes to A2 such that L2 goes to E2. Okay, dot. AN is an event that Ln goes to En. So what do we need to find out? Derangement will be equal to, from the total number of cases, we need to subtract at least one letter goes to correct envelope. Right, tell me everyone. At least one letter goes to correct envelope. Okay, that means the union of all the cases. This will be equal to n factorial minus number of ways. A1 union A2 union A3 union dot union AN. Okay. So this can be written as n factorial minus n of AIs, summation of n of AIs. Okay, minus n of AI intersection AJ plus n of AI intersection AJ intersection AK. Okay, dot. Okay. So you people tell me, what is the number of ways in which exactly one letter goes to the correct envelope? Tell me. What is the number of ways? I mean, exactly one letter should go to the correct envelope. Tell me. Can anyone tell me? Raise your hand.
Sir, exactly one letter in the correct envelope.
Yes, exactly. N of exactly one letter goes to the correct envelope. Tell me. In how many ways? Can you put exactly one letter in the correct envelope?
N ways, sir.
N ways.
Or
First of all, you will select the letter to put it in the correct envelope. In how many ways can
NC1.
you?
NC1.
NC1. And the remaining letters can arrange themselves in whatever way they can. So n minus 1 whole factorial. Right, tell me everyone. First of all, you will select a letter which will go to the correct envelope. And the remaining number of letters can arrange themselves in whatever ways they want. Right, tell me. Raktim, Anandit, Sarthak, Devang, Shomita, are you people getting?
Yes.
Yes, sir.
So similarly, someone tell me what is the next one? Exactly two letters go to the correct envelope. Tell me. Exactly two of the letters go to the correct envelope.
Minus 2 factorial.
NC2 into n minus 2 whole factorial. Correct. Plus NC3 into n minus 3 whole factorial. Dot. Now what I'm going to do is I'm going to take n factorial common. When you take n factorial common, within brackets you are going to get 1 minus. Can you people understand that this was also n factorial, right? So it will become minus 1. Okay. Plus nc2 into n minus 2 whole factorial. When you divide it by n factorial, it will become, pay attention everyone, nc2 is n factorial divided by 2 factorial into n minus 2 whole factorial multiplied by n minus 2 whole factorial. Okay, so these two gets cancelled. And when you divide it by n factorial, these two gets cancelled. You are going to get 1 by 2 factorial. Are you people able to understand? Tell me. Plus 1 by, next one will become minus 1 by 3 factorial. Then plus 1 by 4 factorial. Dot, 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 up to infinity. If there's anyone having any doubt, you can ask me. So hence, the result follows. Tell me, are you people able to understand this proof also? Which one was better? Tell me.
First two.
First one. Okay. N factorial into 1 by 1 by 0 factorial, minus 1 by 1 factorial, plus 1 by 2 factorial, minus 1 by 3 factorial, dot, 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 dot. Minus 1 to the power n upon n factorial. Tell me, Shomita, you have any doubt? Tell me. You can ask me now.
No, sir.
And Raktim, Devang, Anandit, you people have any doubt?
No, sir.
Sokrit, you have any doubt?
No, sir.
Sarthak?
No, sir.
So I think we can do some problems. Okay. So let us discuss. I'm posting the questions in few seconds. Isn't it? Keep sending your answers. Okay, these are the first two questions for today. Once you have done it, send your answers. Should I start, everyone? Tell me.
No, 1 minute.
Sir, please wait.
Okay. Yes, Raktim, number 1 is correct. Sarthak, number 1 is correct. Sokrit, number 1 is correct. Okay. Shomita, number 1 is correct. So Devang, Anandit, only 2 people are left, I guess. Sokrit, number 2 is correct. Anandit, number 1 is correct. Okay, I think only Devank is left. Devank, should I start? Pay attention. Number 1. 4 letters are to be kept in 4 directed envelopes. Find the number of ways if none of the letters goes to its own envelope. What do we need? Tell me, Devank. 4 letters should not go to its directed envelope. So we need to find out D4. Right, tell me, Devang. Yes or no? So D4 will be equal to 4 factorial into 1 by 1 factorial minus 1 by 0 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. After this, what did you do? Did you take LCM?
Yes, sir.
Why? Multiply. 24 minus these two gets cancelled. 24 by 2 factorial is 12 minus 4 plus 1, which is 9. Two-line problem. Why did you take LCM? Cannot understand. It's very simple. Is it clear?
Yes, sir.
Go on, solve number 2, everyone. Okay, should I start, everyone? Yes, Shomita, right answer.
Still one minute.
Okay, solve quickly. Sarthak, check number 2. Raktim, 2 is correct. Sarthak, check number 2. Okay, let us start. A person writes letters to 6 friends and addresses the corresponding envelopes. In how many ways can the letters be placed in the envelopes so that at least 2 of them are in the wrong envelope? Okay, at least 2 of them in the wrong envelope means total minus all, correct? Right, tell me.
Sir, is it 719?
719 is correct. Right. At least 2 of them in the wrong envelope will be equal to total minus all, correct? Which will give us, what is the total number of ways in which you can put 6 letters into 6 envelopes? 6 factorial
6 factorial minus
minus all, correct, is 1. So 719. Tell me, Sarthak, is it clear?
Yes.
Anandit, have you understood?
Yes, sir.
Okay. Moving on to the next one. Okay, I'm posting 2 more. Wait a minute. Okay. I hope you people can read it properly. Okay. See, number 4 came in advance, 2014. Sarthak 3 part 1 is correct. Raktim 3 part 1 is correct. Software 3 part 1 is correct. Check part 2. Sarthak, check 3 part 2. Software, this is the answer of 3 part 2, the latest
Yes,
one
sir.
which you sent.
Yes, sir.
Now check it again. Raktim, check your answer again. 3 part 2. Correct. Devang, 3 part 1 is correct. Anandit, check 3 part 1. Okay, so Anandit, I'm one. A person writes a letter to 5 friends and addresses to the corresponding envelopes. In how many ways can the letters be placed in the envelope so that
Sir,
all
I've
the
sent
letters
you
are
the
in the
right
wrong envelope?
answer.
All yes, now it is correct. So everyone, I'm solving part B. Case. In part B, at least 3 of them are in the wrong
So
envelopes.
sorry
Pay
to interrupt,
attention.
but like it means 3 plus 4 plus 5.
Uh, at least 3 means it can be
3, it
3,
can
it
be
can be
4, it can
4,
be
it
5
can be
also. We have to find the number and then
exactly.
cases.
Exactly. So let us start. Okay. At least 3. At least 3 of them in wrong envelopes. Okay. I think Devank has sent. Let me see. Yes, Devank, your answer is correct. So at least 3 of them in the wrong envelopes. Okay. So everyone pay attention. So it can be equal to all of them in the wrong envelope plus any 4 plus any 3. Okay. All of them in the wrong envelope is D5 plus any 4. Any 4 means first of all you select those 4. First of all, you select those 4 letters which are in the wrong envelope, multiplied by D4 plus any 3 means, first of all, you select 3 letters which are in the wrong envelope, multiplied by D3. Now let us add. D5 is 44 plus 5 into D4 is 9 plus 10 into D3 is equal to 2. That gives us 44 plus 45, 44 plus 45 plus 20. That gives us 109. Tell me, is it clear to everyone? Anandit, Raktim, Sarthak, Sokrit, is it clear?
Yes, sir.
Yes.
Okay. Okay, so everyone solved number 6, number 4. Okay. Shwamita, check number 4. Quickly solve.
So I have a doubt in the 3B. Here can't we apply that method, total minus this one?
Yes, but then you have to subtract any one. Are you getting? You have to subtract any one, and then you have to subtract any two, and then you have to subtract all. Are you getting? You have to subtract
Okay,
3 cases. Either you add 3 cases or you subtract 3 cases. Yes, Socrates,
okay,
number
sir.
4 is correct. Okay, I'm solving number 4. Okay, before solving number 4, let me see who has done it. Oh, Sarthak, check your answer again. Okay. Okay, Socrates, your answer. Socrates, can you explain a little bit how, what is your process? Hello, Socrates, can you hear me?
Sir, actually, I have done it by a different thing. First, what I did was I have considered that card number. So, card number 1 is not going into envelope number 2. Okay. But all other cases. And total number of ways of dearrangement, I have subtracted them.
Card number 1 does not goes to envelope number 2.
Yes. And total number of ways. Or otherwise, sir, we can also do it by case work. Like 2 possibilities can be there, that if card number 2 goes in envelope 1, then dearrangement of 4 things. And then if card number 2 doesn't go into envelope number 1, then dearrangement of 5 things. So 44 plus 9, that is 53.
Wait a minute. I have to understand it properly, what you did. Okay. So first of all, you have taken that card number 1 does not goes to envelope number
No, I
2.
have taken with card number 2. Say, like the next thing that I said was that if card number 1 is placed in envelope number 2, then there can be 2 possibilities. Number 1, that card number 2 is going into envelope number 1, or card number
Okay.
2 is not going into envelope number 1.
Correct.
Now, how can I find the number of ways in which card number 2 does not go into envelope number 1? Dearrangement of 5 things, 5 factorial into 1 by that way. So that is 44. And if card
Correct.
number 2 goes into envelope 1, that means what?
Then
6
D4.
cards are there. 1 is done. 2 is also done. 4 cards are left. Dearrangement of
Correct.
4
Correct.
things is 9.
Correct.
So 44 plus
Absolutely.
10, 53.
Absolutely correct. Absolutely correct. Okay. Next. Okay. So Shomita, did you understand which case you are missing? Tell me. You are actually missing out on a case.
Yes, sir. I'm
You have just
doing it.
taken only one of the case.
Yes, sir.
But anyways, I'll do it by unitary method. Pay attention. You people have done unitary method in class 4. So pay attention. I'll do it by unitary method. Okay. So there are 6 cards and 6 envelopes. Okay. Okay. So what is the number of ways to dearrange? D6. What is D6? Tell me everyone. 6 factorial into 1 by 0 factorial minus 1 by 1 factorial minus 1 by 2 factorial plus 1 by 2 factorial. First of all, let us dearrange all of them. Okay, up to uh, plus 1 by 6 factorial. Okay, this will give us how much? 6 factorial 720 by 2, 360. 360 minus 720 divided by 6, 120 plus 720 divided by 24, 30. Okay. Then 720 divided by 5 factorial. The 120. So 6 plus 1. This gives us how much? Tell me everyone. I have dearranged all the 6 letters. This will give us how much?
265, sir.
264.
265, not
Yes.
264. Right. Next. In these 265 cases, okay, let us say that there are X number of cases in which, okay, suppose there are X number of cases when, wait a minute, when C1 goes to envelope 2, right? C1 hasn't gone to envelope 1. C1 goes to envelope 2, right? Then there will be X number of cases, same number of cases when C1 goes to E3, right? Tell me everyone. Same number of cases when C1 goes to E4, same number of cases when C1 goes to E5, same number of cases when E1 goes to E6, right? So there are 5 symmetric cases.
So
Okay,
265 by 5.
exactly. So the
So
number of
this
ways
method
will
was
be,
easier actually.
yes, unitary method. B6 by 5. So if you understand the symmetry, you can do it in 2 lines. This will give us 265 by 5. That is 53. Tell me, Raktim, Devang, Sarthak, Anandit, is it clear? Shamita, is it clear? Hello, tell
Yes,
me
sir.
what happened, everyone.
Yes.
Tell me, Raktim, is it clear?
Yes, sir.
Devang, Anandit, is it clear?
Yes, sir. Sir, can you scroll up once?
Yes. One last problem, everyone. This completes your chapter.
Yes, sir. Done.
Today only we can start with a new chapter.
Sir, done.
Done. Okay.
Yes, sir.
One last problem, everyone. This completes PNC. This is the last problem, everyone. Solve quickly. Okay, Socrates, number 5 is correct. Okay, so everyone, I'm starting with 5. Pay attention. We need to find out the number of ways in which 13 identical apples can be distributed among 3 persons so that no person receive equal number of apples and each can receive any number of apples. Okay, means no 2 persons receive equal number of apples, or we have to find out the number of ways in which 13 can be partitioned into 3 unequal natural parts. Okay, Acha, tell me, what is the total ways to distribute apples?
13 plus 3 minus 1, C3 minus 1. That is 105.
Exactly, total ways to distribute will be equal to 13 plus 3 minus 1, C3 minus 1. That gives us how much? 105. Okay, so there are 105 cases. Now over here, I'm going to subtract those cases when 2 of them receives equal number of apples. That is 0, 0, 13. Right. This is one of the possibility. Right. Tell me, everyone. But like this, there will be how many cases? 0, 0, 13, there will be how many cases? Tell me, everyone.
Sir, 7 into 3, 21 such cases.
No, for 0 to 13 only.
Acha,
There will be 3
3
cases.
cases, yes. There will be similarly 7 such possibilities into 3.
Then 1, 1, 11. Again 3 cases. Then 2, 2, 9. Again 3 cases. Then 3, 3, 7. Again 3 cases. And 4, 4, 5. Again 3 cases. And 5, 5, 3. Again 3 cases. And 6, 6, 1. Then again 3 cases. But actually there will be one more case. Acha, no. These are the only cases.
Yes, sir.
Okay. So number of ways. Number of
105
ways.
minus 7 into 3.
105 minus 7 into 3, which will give us how much?
84.
84. Is it clear to everyone? Tell me. Raktim, Anandit,
Yes, sir.
Devang, Sarthak, is it clear?
Yes, sir.
Shamita, have you understood?
Yes, sir.
So congratulations everyone. One more chapter is complete. We can move on to another chapter. Okay. So today I'm going to start with a new topic, that is binomial theorem. Pay attention. Let us start. Binomial theorem. Okay, binomial theorem. So first of all, let us understand what are binomial expressions. You people know already binomial expression. Bi means two. Binomial expressions. Okay, that is x minus y, x plus y. Okay, x plus 1 by x, consisting of only two terms. Consisting of two terms. Okay, next. But we can make any expression binomial. Okay, according to our demand. We can make any expression, that is x to the power 4 plus x cube plus x square plus 2x plus 7 also binomial. Okay, by grouping the first three terms and the last two terms. Are you getting, Sarthak? Tell me.
Yes, sir.
You can group in any way you like. Okay, but by grouping you can make any expression binomial. Okay, next. So binomial theorem. Okay, binomial theorem. You people know certain formulas, certain basic formulas. Okay, I'm directly writing x plus y whole to the power n. X plus y whole to the power n is equal to nc0 into x to the power n plus nc1 into x to the power n minus 1 into y plus nc2 into x to the power n minus 2 into y square plus dot plus ncn into y to the power n for all n belongs to natural numbers. For n belongs to natural numbers. What is the first term, everyone? T1 is equal to nc0 x to the power n. What is T2? T2 is equal to nc1 into x to the power n minus 1 into y. Okay. So dot. Similarly, you people tell me what is TR plus 1? Tell me.
NCR
NCR
x
x
n minus
plus
r
y to the
y r.
power.
NCR x to the power
X
n minus
yes
r
into y to the power.
into y to the power r. This is a general term. Okay, everyone. Remember this by heart. Okay, don't forget. Okay, general term. TR plus 1 is equal to NCR into x to the power n minus r into y to the power r. Okay, there are some conclusions we can draw. There are some conclusions we can draw. Number one, what is the number of terms? Tell me. Number of terms will be equal to how many
N
terms
plus
will be
1.
there in the expansion?
N plus 1.
N plus 1. Next, number two, x plus y whole to the power n can be written in the shorthand form, that is summation of r equal to 0 to n NCR into x to the power n minus r into y to the power r. Next, number 3, sum of powers of each term. What will be the sum of powers of each term?
Sir, n itself.
Will be equal to n. You people can see sum of powers will always be equal to n. Okay. Next. Acha, I'm going to write down the proof. Okay, everyone. Proof of binomial theorem. Okay, number 4. Proof, that is x plus y whole to the power n. How it is coming? How x plus y whole to the power n is equal to nc0 into x to the power n plus nc1 into x to the power n minus 1 into y plus dot 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 plus ncn y to the power n. Okay, let us see the proof. So everyone, x plus y whole to the power n can be written as x plus y into x plus y into x plus y dot 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 up to x plus y. How many times I have multiplied x plus y? N
Sir, n
times?
times. N times.
Okay. Now, the general variable, okay, general term is the general variable, or you can say general term is x to the power n minus r, y to the power r. This is how it moves on. Okay. The sum of both the powers will be equal to n. Okay. Achha, now you people tell me, what is the number of ways to select, to choose n minus r axis? N minus r axis will be selected from n minus r brackets? Yes or no? Tell me, everyone. If I want the power 3, I need to select any of the 3 brackets? Yes or no? Tell me. To multiply? Yes or no? Tell me, everyone. How will you get x cube? By selecting any of the 3 brackets? Yes or no? So over here also, if I want to get n minus r powers, n minus r powers will be selected from n minus r brackets. So number of ways to choose n minus r axis will be equal to ncn minus r. Are you getting, everyone? Tell me, which can be written as ncr. Okay. So total number of terms. So total number of terms with x to the power n minus r into y to the power r as a variable. Shomita, are you getting? Tell me.
Yes, sir.
Is equal to NCR. Raktim, Anandit, Devang, are you people getting? Tell me.
Yes, sir.
Okay. Therefore, what is the general term? What is the general term, everyone? General term is equal to NCR x to the power n minus r into y to the power r. Remember, this is the general term. So hence, if I want to write down the whole summation from r equal to 0 to n, x plus y whole to the power n is equal to summation of r equal to 0 to n NCR into x to the power n minus r into y to the power r. Hence proved. Tell me, is it clear to everyone? Raktim, Devang, Anandit, Shomita, are you people getting?
Yes, sir.
Okay. So just like over here, the number of terms in the expansion is equal to n plus 1. Over here, number 5. I'll give you a basic idea about multinomial theorem also, okay? So number of terms in the expansion, of x1 plus x2 plus x3 plus dot plus xp whole to the power n. If I want to find out the number of terms in the expansion of this multinomial, it will be equal to n plus p minus 1, cp minus 1. Okay. How are we getting this? Let us see the proof. So everyone, what is the general term? What's the general term over here? It must be x1 to the power some power, x1 to the power some power, x2 to the power some other power, x3 to the power some other power, dot, xp to the power some other power, right? And R1 plus R2 plus RP should be equal to, what should be the value? Tell me. Sum of all the power should be equal to how much?
N, sir.
N.
So distributing
So
n coins among p beggars.
exactly. It's like distributing n coins among p beggars. Okay. So what is the number of non-negative integral solution? Non-negative integral solutions will be equal to integral solutions is n plus p minus 1 cp minus 1. Tell me. Raktim, Devank, Anandit, Sarthak, Socrates, Shomita, are you people getting? Tell me.
Yes, sir.
Tell me, Devank, Anandit, are you people there or slept?
Yes, sir.
Okay. Raktim, is it clear?
Yes, sir.
Okay. So let us do one problem. Question number 1. Find the number of terms. If you people have understood, tell me, find the number of terms in x plus y plus z whole to the power 8. Calculate quickly and tell me. Socrates, number 1 is correct. Others also sent. It's very easy. Devank, I have already written 8. It's x plus y whole to the power 8, y plus z whole to the power 8.
Oh, yes, sir. I didn't notice. Sorry, sir.
Okay. Raktim, your answer is correct. Shamita, check your answer again.
Sir, I've typed the answer.
Yes, now it is correct. Yes, Sathok, right answer. Yes, Anandit, right answer. Okay, Swamita, I'm solving this one. Swamita, you just apply the formula. Over here, there are how many bakers?
Sir, I have sent the answer.
Yes, now it is correct. So it is 45. Okay, next. So number 6. Okay, NC0, NC1, NC2, dot, NCN are known as binomial coefficients. Okay, NC0, NC1, NC2 up to NCN are known as binomial coefficients. Generally written as C0, C1, C2 up to Cn. Okay, next number 7. Sum of all binomial coefficients. Sum of all binomial coefficients. Okay, let us see. What is the sum of all the binomial coefficients? That is C0 plus C1. This we have already done it before. Plus C2 plus up to Cn is equal to 2 to the power n. Okay, let us see the proof. So we know that x plus y is equal to x plus y whole to the power n is equal to C0 x to the power n plus C1 x to the power n minus 1 into y plus C2 x to the power n minus 2 into y squared plus dot plus Cn y to the power n. Okay, so in order to replace all the variables, what should we substitute in place of x and y? Tell me. In order to eliminate all the variables, what should we substitute in place of x and y?
1 and minus 1.
Only one. X is equal to y equal to 1, isn't it?
Yes, sir. Yes, sir. We have to
You'll get
substitute all.
1 plus 1 held to the power n will be equal to C0 plus C1 plus C2 plus up to Cn. So hence proved. Okay, which will give us 2 to the power n. Okay, next. Also note it down. If you are getting x plus 2y whole squared, this is equal to x square plus 4xy plus 4y square. Over here, what is the sum of all the coefficients? Tell me. Sum of coefficients is? What is the sum of all the coefficients?
Sir, 9.
9. 1 plus 4, 9. Okay. So see, but over here, if I ask you, what is the sum of binomial coefficients? If I ask you in this case only, what is the sum of binomial coefficients?
Shouldn't this be 9 as well?
Sum of binomial coefficients will be equal to 2 squared, which is 4. Okay.
So how?
Coefficients means, huh?
How?
Binomial coefficients means only C, C1 and C2, nothing else. Okay. So it will be 2C0, 2C1 and 2C2. Now you add, how much are you getting? 4. So there is a difference between coefficients and binomial coefficients. Okay. So in exam, you need to be careful.
Sir, can you
Okay.
generalize this? I mean, in generalized expression to find the value instead of putting it
Yes.
every time and calculating.
Yes, exactly. No, for sum of coefficients, you have to substitute the value. But sum of binomial coefficients, you can directly find out. Are you getting? Sum of binomial coefficients, you can directly find out. But sum of
Yes, sir.
coefficients, you have to substitute only. You have no other choice. Are you getting?
Means to find the entire expression, right? Yes.
Exactly. So over here, so over here, you can say to find out the sum of all the coefficients. To find sum of all coefficients. To find sum of all coefficients. Okay. Put all variables is equal to 1. Put all variables as 1. Okay. Substitute all the variables equal to 1. You will get sum of all the sum of all the coefficients. Okay. Next. Binomial coefficients. Binomial coefficients of terms beginning and end. Of terms beginning and end are same. That is, NC0 is equal to NCN. NC1 is equal to NCN minus 1. Okay, dot, 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 dot. Okay. Next, if I ask you to find out the expansion of x minus y whole to the power n, over here, instead of y, you need to substitute minus y. Okay. So x minus y whole to the power n will be
So
equal to
same expression, except there will be 1 minus 1 to the power n multiplied.
exactly minus y whole to the power n. This will be equal to nc0 x to the power n minus nc1 x to the power n minus 1 into y plus nc2. So alternately, it will be positive, negative, positive, negative, positive, negative. It will go on so on. Please. nc2 into x to the power n minus 2 into y squared. Okay. Minus dot. Ultimately, you are going to get minus 1 whole to the power n ncn y to the power n. Tell me. Anyone having any doubt, you can ask me. Next, there are some special expansions, special identities which are important. That is 1 plus x whole to the power n. 1 plus x whole to the power n is equal to c0 plus c1x plus c2x square plus c3x cube plus dot 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 plus cnx to the power n. Okay. You see, every year a lot of questions come from binomial also. If you see PYQs, you will see in every shift, every paper, you will get at least 1 or 2 questions sometimes from binomial. So it's an important topic. 1 minus x whole to the power n will be equal to c0 minus c1x plus c2x squared minus c3x cube dot 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 minus 1 whole to the power n into cnx to the power n. Okay. So everyone, let us do some problems. Anyone having any doubt till now? Tell me. Shomita, Devang, Raktim, Anandit. Anyone having any doubt? Tell me. Sokrit, you have any doubt?
No, sir.
No, sir.
Okay. And Sarthak?
No, sir.
Okay. I'm posting questions. Wait. Okay. Just give me 1 minute. Okay. Quickly solve. Okay. Improve your speed, everyone. This is an easy chapter. I want to complete it quickly. So everyone's exam is over, right? Devang, your
Yes,
exams
sir.
are over. No.
Yes, sir.
Shomita, when will your exam get over?
Sir, it will start from 23rd and end on March 9th.
So late. Shomita. Start on 23rd. Ends on March 9th. So late. And for DPS, when does the school starts? New session?
Sir, actually, they have means they have decided to have extra classes from 10th of March. Means not regular classes. The regular session will begin from 10th of April.
Yes, sir.
Regular session will begin from, and what are these extra classes?
So the syllabus will begin from 10th March only.
So basically they are starting the session from 10th March only.
Hmm. That
Yes, sir.
is what happens every year.
Yes, sir. Yes, sir. For 9 and 12.
So much pressure. What to do? And Shomita, when will your science exam ends?
Sir, March 9th is my maths exam. It will end with the maths exam.
End with the maths exam. So only the last few exams are important.
Sir, like in the first week, the second and third exam are physics, chemistry, then I have bio, and then English and maths.
So from the beginning till the end, you have to study only. Can't
Yes,
help
sir.
it. Okay, solve. What to do? I was thinking of taking some extra classes. But anyways, then in that case, on Tuesdays, yes, Sarthak, your answer is correct. Socrates number 3 is correct. Devang, Devang, check 2 part 1. What happened, everyone? Quickly solve. Socrates 2 part 1 and 2 are correct. Should I start, everyone? Tell me. Raktim 2 part 1 and 2 are correct.
Sir, 2 part
Anandit
1 is 2x square minus 3x plus 2, or is it 3?
plus 3.
Oh, I understood. Okay, sir.
Shomita, check 2 part 1. It is plus 3. It is plus 3. I I know it can be confusing. Okay. Yes, Devang 2 part 1 is correct. Socrates, check number 4. Shomita, this is the answer of 2 part 1.
Yes, sir.
Oh, Shomita, you are making a mistake. Shomita, in order to find out sum of all the coefficients, not binomial coefficients, what do we need to do? Tell me.
All the variables as 1.
1. So substitute 1. When you put 1, what are we getting? 2 minus 3 plus 3 whole to the power 2026. Which will give us 2 to the power 2026. Tell me. Are you getting, Shomita?
Yes, sir.
Okay. Sarthak, there is a slight mistake. Yes, Socrates 4 is correct now. Devank, number 3 is correct. Shomita, 2 part 2 is correct. Raktin, check number 3. Anandit, 2 part 2 is correct. So I think 2 part 2, everyone has solved it. So I'm not solving. 2 part 2 is the easiest of all the problems. Yes, Socrates question number 5 is also correct. Everyone quickly solve. You people are taking too much time in such an easy chapter. Okay, I'm starting with number 3 then. Devank, number 4 is correct. Anandit, 3 is correct. Okay, Raktim, I'm starting with 3. Shomita, 3 is correct. So, Raktim, can you see? It can be written as 1 plus x whole to the power 15.
Yes.
Tell me, yes or
Yes.
no? Sarthak, 4 is correct. This is equal to 1 plus x whole to the power 45. What is the coefficient of x to the power 6? Therefore, coefficient of x to the power 6 will be equal to 45c6. Is it clear? Is it clear, Raktim?
Yes, and I understand.
Quickly solve part 4, question 4 and 5. Don't take too much time. Question 4 and 5, everyone solve quickly. Shomita, there is a slight mistake. Andit, there is a slight mistake. Yes, Raktim, number 4 is correct. Yes, Sarthak, number 5 is correct. Okay, so Shomita, Raktim, Shomita and Anandit, I'm solving number 4. Pay attention. Yes, Anandit, now it is correct. So Shomita, pay attention. Find the fourth term. Fourth term will be T3 plus 1,
Yes.
which is equal to 7C3 into 2x whole to the power 7 minus 3 into minus y power 3. Right? This will give us how much? Minus 35 to the 35 into 2 cubed. Wait a minute. 35 into 2 to the power 4 divided by 2 cubed. So this will get cancelled. Only 2 will be left. Can you understand?
Yes, sir.
So minus 70x to the power 4 y
Yes,
cubed.
sir.
Tell
I
me, is it
missed the
clear?
y cube.
Shomita? Okay. Number 5 is absolutely correct. Okay. Anandit, 5 is correct. So who is left for 5? Okay. So I think Raktim and Anandit. So Raktim and Anandit, pay attention. Number 5. We need to find out the term involving x cube. Okay. So first of all, you write down the general term. TR plus 1 is equal to 6CR into 2x square whole to the power 6 minus R multiplied by minus 1 by 3x whole to the power R. So over here, what is the power of x? Tell me, Raktim, Anandit. What is the degree of x?
Sir, 2 into 6 minus R by minus R.
Degree of x will be equal to 12 minus 2R minus R. This should be equal to 3, right? So what is the value of R? R should be equal to 3. Hence, T3 plus 1 will give us the x cube term. That is 6C3 into 2 cubed into minus 1 by 3 whole cubed into x cubed. This will be equal to 63 is how much? 20. 20 into
20
8
into 8 by minus 27.
by minus
It's
27. Absolutely correct. See, sir, very simple. You must have done it in your school also. Right, Raktim? Watch out. Okay. Next. Question number 6. Find the term independent of x. It's a very common question, everyone.
Sir, how many more questions are there?
Uh, how many? There are a lot. You can
No, I
never
mean,
run out of question when I'm taking a class, right? Like what? You have some work today.
no, I just asked.
Oh, there are infinitely many questions. Have you people ever heard of Hilbert's infinite paradox? Tell me. Did you people ever heard of Hilbert's infinite hotel paradox? Tell me. It's an interesting paradox. Go through it once. Okay, should I start? Term independent of
Sir,
x.
sending. Sir, sending you the answer. Sending you the answer.
Quickly, it is similar to question number 5. These are very small problems, easy problems. Should hardly take 30 seconds to solve. Yes, Sarthak, your answer is correct. Shamita, your answer is correct. Devang, there's a slight mistake. Socrates, your answer is correct. Anandit, your answer is correct. So only Raktim and Devang is left.
So please wait, I'm checking
Sir,
once.
1 minute, send.
Send quickly. So tomorrow, those who are attending the class, everyone is attending the class, right? Tell me. Anandit,
Yes.
Devang,
Yes, sir.
those who are attending the
Sir,
class.
Yes, sir.
tomorrow.
Ah, yes, Devang.
Tomorrow, yes, sir. Yes.
Right. Okay. So tomorrow, can we start from 8:30 again?
Yes, sir.
Tell me. Devang?
Yes.
Yes, sir.
Okay. Devang, check number. No, Devang, your answer is correct. So everyone has got 20 by 27. So tomorrow's class will start from 8:30. Okay. Tomorrow's class from 8:30.
So
Okay.
tomorrow's class will be till 11:30 or 10:30.
Let's see. It can extend 11. I don't know. Let's see. It depends upon the topics I need to cover tomorrow. Okay.
Okay, sir.
After that, you don't have a class, right? Tell me.
No, sir.
Okay. Then what is the problem?
Sir, tomorrow from when?
From 8:30.
Okay, sir.
Okay. How to find out the middle term? Okay, everyone pay attention. Middle term. How to find out the middle term? Case 1. There will be two cases when n is even. When n is even, that means the power is even. So if the power is even, everyone, what is the number of terms? What is the number of terms? Tell me.
Number of terms will be n plus 1 only.
N plus 1. Absolutely correct. So what is the middle term? Middle term will be n by 2 plus 1. Yes or no? So t n by 2 plus 1 will be equal to nc n by 2. X to the power n by 2, y to the power n by 2. Remember, like
So
for
only if n
example,
is even.
if n is even, for n odd, that also I'll explain. For example, middle term in x plus y whole to the power will be equal to t3 plus 1, which is equal to 4. Wait a minute. 4 divided by 2. 2 no, so t2 plus 1. 4c2 x squared y squared. Remember, this is the middle term. Next. Case 2. When n is odd. So over here, how many middle terms we'll get? Tell me everyone.
Two term. One will be n plus 1 by 2 and one will be n plus 3 by 2.
Exactly. For example, I'll give you an example, you will understand. X plus y whole cubed. This is equal to x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay. What is the number of terms? Number of terms is 4 or n plus 1 you can say. Acha, n plus 1 is even now. Okay, within brackets you write down even. So we'll get two middle terms. Two middle terms. Okay. That is n plus 1 by 2th term and n plus 1 by 2 plus 1th term. Are you people getting? Tell me. Yes or no? Okay. And what will be the coefficient of these terms? Coefficient of terms will be nc n plus 1 by 2 minus 1 and nc n plus 1 by 2 only and plus 1 minus 1 will get cancelled. This will give us nc n minus 1 by 2 and nc n plus 1 by 2. See, you people don't need to remember this. Okay, you can manually count, right? Like for example, if I ask you, if n equal to 17, what will be the middle terms? Tell me everyone. If n equal to 17, what will be the middle terms? The number of terms will be 18. Middle terms will be equal to
9 and 10. 9th term and 10th term.
9th and 10th. Are you people getting how you can calculate quickly? Hello. Are you people getting? Tell me, everyone.
Yes, sir.
Okay. Shomita, are you getting? Shomita, Devang, Anandit,
Yes, sir.
Yes, sir.
Raktim,
Yes,
are you
sir.
getting?
Yes,
Okay,
sir.
everyone. We can do one last two problems. Okay. Tomorrow we'll again continue. Last two problems, everyone. Quickly solve. Okay. 7 and 8. Quickly solve. We need to find out the middle term in the expansion of 2x squared minus 1 by 3x whole to the power 11. And the next one, calculate quickly last two terms, last two problems. Everyone should get it correct. Okay, you can just write down the expression if you want. Sarthak, there is a slight mistake. You did everything
Oh, yes,
correctly,
sir, is a
but
sign.
uh, so Devank, you are making some mistake. Shomita, you are making some mistake in 7.
So just writing the expressions would do.
Only write down the expression, no need to simplify. I'll be able to understand. Raktim, how many middle terms will be there? Shomita, check number 8. Don't make mistakes in these kind of problems. Yes, Socrates, your answers are correct. Sarthak, your answers are correct. Devang, your answers are correct. Okay, let us start. Yes, Socrates number 8 is correct. Okay, let us start with 7, everyone. Yes. Anandit, your answer is correct. Raktim, your answer. Raktim, there is a slight mistake. But technically you are correct, but still there's a slight mistake.
No, no,
Technically you
sir.
are correct.
Sir, one should be 1165. That thing.
But anyways, it's correct
And
only.
actually, I know that, but I wrote it.
No problem. Okay, find the middle term in the expansion. So over here, middle terms will be, okay, pay attention. Number of terms will be equal to 12. So middle terms are 6th and 7th terms. So this implies R should be equal to 5 and 6. This implies P5 plus 1 will be equal to 11C5 into 2x squared whole to the power 11 minus 5, that is 6. Wait, 2x squared whole to the power 6 into minus 1 by 3x whole to the power 6, 5. And T6 plus 1 are equal to 6. Okay, T6 plus 1 will be equal to 11C6 into 2x square whole to the power 5 into minus 1 by 3x whole to the power 6. Remember. Last one, quickly solve everyone. 8. Shomita, you have done it like this only, right? Number 7.
Yes, sir.
Sarthak, your answer is correct. So Shomita, one of them you should have got negative, right? You have done a mistake.
It's a calculation error.
Again, Devang, there is a slight mistake. Okay, I'm solving everyone. Number 8. In number 8, we need to find out the coefficient of x to the power 15 in x minus x square whole to the power 10. So what you do is you take x to the power 10 common. After taking x to the power 10 common, you are getting 1 minus x whole to the power 10. So over here, what should be the coefficient? What coefficient we are looking for? Whose coefficient we are looking for? Tell me. I've already got x to the power 10. So over here, I need
X
the
to the power
coefficient
5.
of, we need the coefficient of x to the power 5 over here. X to the power 5, which will be equal to minus 10C5. Okay, remember, it will be negative, which is equal to minus 252. Is it clear? Tell me. Raktim, Sarthak, your answer is correct. Devang, is it clear? Devang, Shomita, is it clear? Anandit, is it clear?
Yes, sir.
Yes, sir.
Yes.
Okay. So everyone, I think we can keep it till now. Next class, tomorrow's class will start from 8:30. Okay. Thank you everyone and good night.
Thank you, sir. Good night.
Thank you.
Thank you, sir. Good night.
Good. Yes.